that, we're going to add ferrous sulfate. Listen. Ferrous sulfate. All right, iron. Listen, sulfate. So the iron's all forgot. Great, we're good to go. What's going to happen is a replacement reaction. Remember when we did the copper and silver nitrate lab?
Yes.
Yeah? And the copper and the silver switch places? Same thing's going to happen here. This oxalate, this thing right here, and this sulfate are going to change places. So here's what we're going to end up with. We'll end up with iron, iron oxalate, excuse me, as such, and we'll end up with sulfuric acid. Look what.
And you feel the white bunny.
White blood cell was trying to attack me. Again.
Yeah, it's pretty jerky blood.
I'm not recording this, Eric.
No.
Okay.
He actually is. You've been recording since like.
You want me to not?
No, it's just I'm so short and the white blood cell's so tall.
Do you want some help? Yeah, do you want?
It's okay, I'm short too.
You can go along for the ride. Alright. This is where I rip my shirt, right?
Then you become the host.
Alright. Fantastic. So look what happened. The oxalate that was over here is now attached to the iron. The sulfate that was over here is now attached to the H. We've made sulfuric acid. No, it's not. They just switch places, right? So, great. We're not terribly interested in the sulfuric acid. We're just going to neutralize it and dump it down the drain. What we are interested in is this iron oxalate right there. Here's what we're going to do with it. We're going to take the iron oxalate and we're going to add to it some heat. When we do that, okay, no. So if I wrote this, how would you say that?
Heat.
Hate.
How would we? Okay, all right. We'll play along. How would you say that word? Heat. How would you say that word? At. So.
Yeah.
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 Heat.
Yeah.
Right?
Like that.
No. I'm just saying, maybe this is how most people spell it, but I think that's how it should be spelled. Yeah. Just saying.
Would it mean the same thing?
Yeah.
Then you'll get a Nobel Prize for changing the way heat is spelled.
I don't know about that.
No.
We could always try.
Fine.
But Snape Harry.
This is normal
So,
science.
what happens when we do this? Listen. Is we end up with iron all by itself, and we produce some carbon dioxide. Look, the C and the O's combine to form carbon dioxide. Now we've got very finely powdered iron, and that's what we're after. All right. So here we go. If you'll join me over here, or
Wait, do we need the green and yellow?
you're good. You're good right now. So here's what we need to do, right? Listen. We need to make some iron oxalate because I don't have any iron oxalate hanging around.
Yeah, water.
Luckily, we can make it really easily. We got a little bit of agua. All right, and we'll put a little oxalic acid into it. Here we go. If this were Tuesday or even Wednesday, we would measure, but on Fridays, that's pretty good. A little bit more. Seems good, right? All right, little oxalic acid, fantastic. This stuff takes a little bit of time to dissolve, but we don't really need it all to dissolve. So we'll kind of mix it around, but it's a white powder, and it will dissolve in the water eventually, if I was a patient scientist, but I am not a patient scientist. What we're going to add next is the iron sulfate to it. Get a little bit more of that in there.
Simple's like adding two things together. This is like pretty complicated.
Well, but you're going to see it happen, right? We've got the oxalic acid in there. And when I add the iron sulfate in, the two things are going to switch places. The iron and the oxalate are going to come together. You'll notice that, well, no. Iron sulfate is kind of this tealy, I don't know what kind of color, right? But when I throw it in,
The iron is green.
science. That's probably, maybe like...
How do they make Gatorade?
Makes you wonder, doesn't it?
Yeah.
Yeah. Only this would
Add some sugar in your
well,
stomach.
yeah.
Well, yeah.
Well,
So we're going to mix it together, and look, it's starting to become yellow, clearly. It's also starting to get cloudy. It's clearly getting
Orange
cloudy.
juice.
The reason that it's becoming cloudy is oxalic acid will dissolve in water. Iron sulfate will dissolve in water, but the thing that we're making, the iron oxalate, does not dissolve. It just stuck out from under this. Does not dissolve in water. So it's actually precipitating out, and we're making this kind of
Look at egg.
a little
Center of
like,
egg.
yeah, like egg yolks kind of at this point. Again, you get yourself an issue if you drink it. So now we have all this finely powdered stuff suspended in that water. I want to separate it. I guess I could like wait till it all settles to the bottom and then suck off the water on the top of the straw, but that seems like a bad idea because there would also be sulfuric acid in it. So what I'm going to do is filter it instead. Got myself a piece of filter paper.
Do you?
There it is. Right? Sneaky. Huh? And fold it. Make yourself tacos. Make yourself a piece of pizza. Then open it up.
It's like calling it.
Isn't it? There's a little. Now, one of these sides is going to be a little thicker than the other, but that's okay. The OCD person inside me is screaming too. Don't worry. So we'll kind of spray this with a little bit of water so it sticks to the side of our funnel, and we're good to go. Then all we got to do, stir this up a little bit more. By the way, feel the bottom of that.
Change it back after.
Chili, right?
Yeah.
Endothermic reaction.
Was it cold before?
No. It made the cold.
Whoa.
Rather, it took heat from its environment. So, if you're worried about spilling, just pour down the stirring rod. Look at that.
Wait, are we gonna do this?
No, but in,
Then why do you say it
well,
won't?
in the future, if you're filtering something and you're worried about spilling, well, coffee this way, but and then all we got to do is wait for all the liquid to drip through and collect the solid. It could take a while, right? But here's some I prepared earlier.
No.
It is kind of like a cooking show, isn't it? But wait, there's more. There actually isn't. All I've got. But we're making some more here. So we're going to let that filter. We'll pour a little bit more through. And then eventually it'll dry into this yellow powder that you see here, and we'll collect it and put
Burn
it
it.
here. So what we're going to do now is put some of it in this test tube. And we're going to heat it up. That will cause it to decompose. Then we'll be left with just iron. It produces, remember, listen, it produces carbon dioxide.
Okay. Chemical reaction.
Thank you, Logan. Oh, Friday.
He's like, it's Friday. It's a weird one.
That all sounds good.
It's recording.
Soaking up urine for all of you watching at home.
For science.
Yeah, no, just for fun.
Okay, what? He's going back.
Don't use it.
Just pee on the towel.
Anyway, we're going to load it in here. We're going to heat it up. It will produce a layer of carbon dioxide that will prevent it from rusting. When I dump it upside down, what will happen is the iron will fall through the air that contains oxygen, and it will rust instantly before it hits the table. You'll actually be able to see it rust because it will create sparks. It'll get that hot as it rusts.
Don't touch it.
All right? Kind of, because it's got a large surface area. It rusts really quickly. Yes?
Oh, yeah.
Now we're with number 2.
Well, we have a match set now.
Told you. Look at his face. He's like, I didn't do it.
Yeah.
Alicia,
I can't tell you how
Occupational hazard.
a few moments ago I took him out.
Oh, he touched it. Disgusting.
Nice and firm.
I could have lived an entire lifetime without knowing that.
Well, could have, but you didn't.
Not anymore.
I know. Kill myself. You're a good dog.
What are we doing now? Putting that in something. I like that. Okay. Sparks. Good.
Ooh.
Yeah.
Hear me.
Ooh, that does smell.
Well, I mean, you know, sometimes, a little more? I'm kind of glad it's staying.
I just put the rest in there.
Well, I mean, coach more. Kind of like more than a pinch, but less than a pinch.
That is coach.
Yeah. So here we go. All that remains for us to do then is to heat it and watch the science happen. Now, to prove to you that this is very hot indeed, I'm going to take a bit of paper towel here, kind of rip it up and put it in here. So when it lands, you'll see all sorts of sparks. So those of you who are in the immediate vicinity, you've got to back up.
Am I far away enough?
You're good. You're good. But those of you like,
Yeah, you guys are too slow.
Wish I could zoom in.
fantastic.
Webcams don't zoom.
Now, this is not going to explode or anything, but, you know, whenever you're heating glass, you want to take any precautions that are necessary. All right? I've inspected the glass to make sure that it is not cracked or chipped in any way. I'm going to hold it with this instead of my hand, because that seems like a better idea. And then we'll heat it up. Now, look at the reaction on the board, right? We're going to take the iron oxalate, which is yellow. We're going to apply heat. We're going to end up with iron and CO2. CO2 is a gas, right? Iron is what color? Brownish, blackish, kind of, right? So that's what we expect to happen. This should start to change colors as we heat it. Heating. Notice I'm keeping the flame moving. Whenever you're heating glassware, you want to make sure you don't heat it unevenly. That could cause one part of it to expand and crack. It is. It's getting darker because we are decomposing that. We're causing that molecule to fall apart. The carbon dioxide is coming out the top. You can't see that because it's carbon dioxide.
I see.
Well, that's a little bit of the vapor, or the dust rather, that's being carried away. But we're left with only iron. It's going to be very, very finely powdered iron. And we'll be able to let it rust instantaneously.
What happens if you inhale it?
Well, all of a sudden,
Yeah. Throw it in the air. Dump it in there and not throw it.
Not the most exciting part, I have to say.
most of the exciting part.
We just got to make sure that it's all changed colors.
Fine, it's exciting.
So keep in mind, carbon dioxide is more dense than other things in air, so we've got a layer of carbon dioxide in this tube, which is why it's not rusting immediately, because there's no oxygen.
Smells like a firecracker.
Maybe. There might be some leftover sulfate from the iron sulfate. All right. Thank you, Miss Freudenwald. So here we go. We've got this in here, all right? And I'm just going to dump it, and before the little bits hit the ground, you'll see sparks. That is them rusting. Ready? There, right? So there you go. Before I actually do start a fire, I'm going to put it out, but you can see that it's smoldering. I mean, we rusted in midair there.
Don't inhale that.
Yeah, well, it smells kind of like rust.
You got a little bit of rust.
So not good.
Yeah, that's okay. And now we've got freshly made rust. So if you are in ever in need of some rust, just talk to your friendly neighborhood science teacher, and we'll get you some fresh homemade rust. I even made the iron oxalate to make the rust.
Professionally made.
I mean, it's high class, homemade, all natural, organic.
I can just leave a piece of metal out in the weather.
If you want to risk that it gets like peed on by a dog or something, yeah. But this, actually, just now that you mention it, but it's fresh rust. There you go. And you saw that it was exothermic. It sparked as it was flying through the oxygen because there was so much surface area.
Nope,
So there you go. Fun stuff.
Do you watch these videos when you get home?
All right, we're good to go. Let's pour a little bit more of this through here. Logan. Nice try. All right, so there's a bit of fruit for you. Nice. We'll tidy this up a little bit later, and you can head back to your desk, please.
Oh no.